Let's get started, and what I'll do is introduce our first speaker, who happens to be with the XRCC team, and our first series of talks this morning are going to be for the XRCC members. So Blake Shares is an immersive technology systems architect at APL. He specializes in adapting commodity technologies for enterprise use, designing application system architectures, and applying sound software engineering practice to research efforts. Blake's primary focus is on maturing highly experimental prototypes and approaches for use in lab-wide research and development efforts. So please welcome Blake Shares.
I know how to use it. Thank you, Nick. I will say, in my previous role at the lab, I never once wore a suit. But that's all right, because I'm having fun with it, right? So this was my decision. I'm having fun with it, because the truth of the matter is I absolutely love what I do. I love my job, and so we're going to be talking about what it is that's going on at APL. And so this is actually 3 talks put together back to back. So we're going to start with an overview of XR at APL. What's been going on, especially in the last year. This is a very dynamic, fast-moving industry, and so there's a lot of changes from year to year. So we're going to be talking about the kinds of work that APL is doing, how that is driving value for our sponsors, and what the main areas are that APL is focusing on. And that's actually going to also provide as a guide to many of the talks that you're going to see at the symposium here today. Then I'm going to talk about the state of the XR industry. So this is something that I've been doing for probably 8 or 9 years as I've been assessing the state of the industry. Now that we have a larger team, every week we go through news articles, we talk about what's going on in the industry and how we think that it impacts us. And then lastly, being that it's 2023 and the software engineering world is changing very rapidly, we're going to be talking about artificial intelligence and the applications of artificial intelligence and how that goes hand in hand with the work that we're doing in immersive technology. So, first of all, our work continues to expand, right? That's what Nick was talking about. Our individual team has started to grow, but we're also seeing it across the lab. We're seeing more and more teams that are using these tools. We're doing a lot more real-time 3D work. So we now have, by the last count, over 300 real-time 3D developers. Now that they're probably not all full-time. I don't know all of them individually. We do have a large cadre, probably 50 plus, that are pretty much full-time, and that is both Unity and Unreal. One of the things that has been a really big shift this last year especially is that we are transitioning from research ideas, novelty, things that are cool and interesting and get attention, and we're understanding how they really drive value. And now we're transitioning to solution-centric engineering. And so really, we're talking about taking the ideas, the tools, the resources that are coming from the broader tech industry, a lot of influence from the entertainment industry, and we're learning ways that we can apply those effectively to take on real-world problems for the DoD, government, warfighter, and scientific communities. So the 4 main areas that APL has been spending most of their effort is digital engineering, training empathy building, human-machine teaming, modeling and simulation. Those are the 4 big areas, so almost every single talk that you're going to hear from an APLer is going to fall into one of those 4 categories. So I'm going to go into a little more detail about each. So one of the things that our team does, because we do not spend all of our time on tasks delivering solutions, where our team is actually split from the very get-go. We have people that are on the teams developing actual solutions so that we understand what's needed, and then we also have infrastructure work to help improve the quality of product across the lab and improve the quality of life for developers so that they can really leverage these tools and resources from all over APL. So one of the things that we do a lot of hardware assessment. So Dr. Blankhorn will have the talk after this one where she is talking about headset optics and rendering. And we have a lot of this hardware available in some of our centralized labs where people can come and try out headsets and experiment with them and play with them instead of every single team having to do their own analysis of alternatives for every single effort that ever goes on, right? So we're centralizing and organizing a lot of those technology resources. Then we also have areas where we're looking to mature the technology. A lot of these are based on, games, right? These are game engines. We call them real-time 3D engines, but that's synonymous with game engine. And they're not designed for use in an enterprise, right? So there's a lot of talk about XR device administration, right? Because instead of having a single console in your home, you're talking about deploying a fleet of devices, right? Or how do you authenticate and tie into enterprise authentication so that you actually know that the users are who you say they are? I'll be honest, a lot of the user interfaces are very bad at passwords, right? Putting a password in on a HoloLens is a nightmare. So how do you do that without driving your users crazy? 3D holographic visuals, headset not included. So again, these are more devices that are available, ways that people can experience things without necessarily having to put on a headset, because there are still social stigmas about putting on a headset and looking silly, or there are still some legitimate fears about people not feeling well after they've used a headset. So there are other ways that you can communicate your real-time 3D content in an interactive way without necessarily having to put on a headset. And then we also, of course, have development. Many of these devices come in, we're just using the hardware, commodity hardware. The software that comes with it isn't going to be good enough. We're developing our own solutions, right? And so we have a number of talks about how we develop things. So elevating programming, FBX to Unity assets, so that's an art-focused topic because art is very important, especially the more sophisticated you get. And then asset milestones and progress for XR developers is also getting into the software engineering pipeline and how you mature things and have appropriate milestones. Digital engineering is one of the core functions of XR at APL. Our team is actually in the same section as our digital engineering team. These people are, absolutely hand in hand. We're doing this stuff together. And so digital engineering is very much at the core and the root of how XR took hold here at APL, right? So we have a number of experiences and talks, and demos as well here about digital engineering. So Apex is a multi-user collaborative engineering environment, which is near and dear to my heart. Vuforia Studio is more of a commercial off-the-shelf product, but how do we use that? How do we leverage that more effectively? And then Ian is going to be talking about the IMAP spacecraft and the instruments in VR. And all of this is also in partnership with digital twins. So anything with a gold star means that we have a talk about it. All of the talks here at the symposium are distribution A, public release. Not all of the work that we do at the lab is distribution A, public release. So there are going to be a number of things that are important themes and topics that we're not going to be presenting at the symposium. Digital twins is an area that is still growing at APL. Now this is an area, it's a little tricky because if you ask two engineers what a digital twin is, you'll get 3 definitions. And, but essentially what we're talking about is having not just a physical model, but also a logical model and essentially a simulation engine tied in with the 3D CAD data so that you can do a number of things, right? Digital twins enable a whole lot of things. First of all, if you have, say, a spacecraft that is orbiting the sun, you may want to get telemetry about it, but you can't actually physically access that asset, right? But you'll get live telemetry and then you have your digital model and that you can see what's going on. You have a better intuition and understanding of what's going on with that asset that you can't get hands-on with. Once you've done that, you can do a number of things. First of all, if there is a component failure or something like that, you can understand it and you can try a few things because you have a model of that spacecraft and how that spacecraft operates. You can also do what-if planning. You might be able to get ahead of some expected failures, right? You might say, hey, we're expecting this component to fail after so many cycles. How can we still achieve good science if that component fails, and you can do that kind of testing. It also provides a wonderful, maybe for assets that aren't out in space, it provides a wonderful training environment as well, or at least the start of a training environment that you can use to be able to practice procedures on those systems. Another area of work that is really taking hold at APL and that we're seeing grow very quickly is training and empathy building. Now, if you are interested in a trainer system that is really designed to educate users, where you can inject faults or that you can really assess how a classroom of people are doing or how people are growing over time, we actually have at APL in FPS a team of folks that is what they do. Right? These are the experts in building trainers. They understand a lot of how the instruction should be done. They have some very high fidelity work that is worth going into in more detail, although some of it is sensitive. And it's not just fully in silica. They also have, in some cases, like physical mock-ups with actual switches that do things, right? So training is a big deal for immersive technology, especially as it applies to a larger regimen of training. So if we think about flight simulators, right? If you're learning how to fly a 747, you don't want to spend all of your simulator time on this giant multi-million-dollar simulator of an actual 747 that they've put on a motion platform, right? You can do a lot of your learning and orientation and understanding on a much lower fidelity simulator where you have better access to it. It's more affordable. You don't have to travel somewhere. You're not, vying for time on the simulator. You do a lot of your training there, and then you work your way up to the giant simulator that's on the motion platform. And so XR as a training tool has been a very big deal, and we think that it is going to continue to extend much more. And we're seeing also in the simulation communities like IETSEC and whatnot, there has been a lot of immersive technology that is really getting into a lot of the trainers and simulators going on there. We're also doing some collaborative work with the Johns Hopkins School, Whiting School. So having experiences like cybersecurity, planning and whatnot that wouldn't necessarily, you're not actually physically standing up hardware and whatnot, that you're able to do that virtually and have an interactive thing and understand the concepts in repeatable ways. That's, a good use of virtual environments and how we do that. When immersive technology, when this round of virtual reality came out originally, one of the things that they talked about is that VR was going to be the great empathy engine. And so a lot of that was from things like the Games for Change Festival or the Serious Games Summit, and a lot of it was revolved around social issues. How do you put one person in the perspective of another person so that they can experience some of the things that others have experienced? And so there's been a large amount of work on that. Now, what's also interesting is that we, as scientists, designers, engineers, are able to use that kind of approach and that kind of technology to understand the warfighter better. APL spends a lot of time and effort in support of the warfighter. The problem is that the warfighters very often have very real problems that the designers and engineers have never had to face themselves. Now, some of us have been lucky enough to go onto a submarine or go onto a surface ship and spend some time and actually get that firsthand experience of what it's like to be there. And that provides extremely valuable perspective, right? Because that's what helps the human factors portion of the human factors engineering, that we're really solving somebody's problem, that we're not just solving a problem for maybe kind of anybody, that there's a name, that there's a role, that there's an experience that they've had that they can relate to and say, yes, I am solving a real problem. And as awesome as it is for those people that are able to go on those ships and have those experiences, frankly, there are more scientists and engineers than there are available opportunities to go on those kinds of experiences. But what we have found is by building these environments, it helps us understand what do these environments really look like? What do they feel like? What are some of the constraints? We've had some human factors things come out of that, right? Somebody said, oh, wow, you need to move this railing down because this railing is too high. I can't see over it. Well, that was the actual height of the railing on the ship. Like, we can't move that, right? But that's important. That informs the human factors for what needs to be done, right? So that empathy building, you're going to hear a fair amount from some of the Tang efforts. They've been really the pioneers in using empathy building to help build human factor-centered design. The VR locomotion system evaluation, again, that's going to be from our friends in the force projection sector. They have some really interesting equipment around locomotion, and so if that's something that you're interested in, tools like an Infinideck or something like that, be sure to check that talk out. And then taking inspiration from the film industry, that's also going to be the Tang team, and again, that gets down to how do we communicate effectively. And the truth of the matter is that the film industry, the media, has been very, very good at communicating a few things, and there's a lot of lessons that we can learn about how we can really take inspiration from them and take those ideas and leverage them. Human-machine teaming is another major area of focus. It's something that is deeply interesting to me. In this case, we're going to talk about human-machine teaming in any kind of human, non-human pairing. And so it could be a human and a robot, it could be a human and a sensor, it could be a human and an algorithm, right? And so there's a lot of work that's being done on that. Expeditionary repair was not ready to be public released at this time, but that's where you have an AI using a classical AI algorithm called GOPE to help strategize most effective ways of diagnosing and solving problems. Because most of the immersive technology that we see today when it comes to mechanical work is based on maintenance, where you're starting from a known good state, as opposed to repair where you're not. The AR Pediatric CPR Coach update, so that's going to be Brandon Scott, he's going to be talking about that. In this case, the machine portion of it is largely driven by a sensor, but as compared to what's being done today, that sensor is providing data to the system, but then the system is providing specific instruction to somebody performing CPR on how they can perform better quality of care. And that's not actually something that's really done a lot today. A lot of the systems just provide raw data. They're not providing information, let alone instruction. Neurally augmented reality, neural decoded spatial location selection. So now we're talking about brain-computer interfaces. This is a very exciting area. It's still early, but some of the folks that we have in red working on that are really just, I think, phenomenal people. They're doing great work. And so if you want to see the next generation of how we may be interacting with computers, check that out. Beyond human reasoning, again, so this is directing people's attention to where it needs to be, when it needs to be there. So that's having an algorithm actually assisting in the performance of a task. Similarly, search and rescue support. And then SpearViz is, again, we're having external sensors and we're working with the machine, right? Because the computers and the sensors can see in ways that humans can't. But right now, humans can reason in ways that other systems can't. And so how do we bring those sensors and that perspective of the world in line with what we need as human operators to be able to accomplish a task? Lastly, modeling and simulation. So this area was really driven a lot by Bob Chalmers and his team with a lot of the swarming simulations and robotic simulations. There is a lot of work that's going on here. Now, much of this work is being applied directly to sponsor problems, which is why we're not getting distribution A public release on a good amount of this. If this is something that interests you, find somebody with a yellow badge or yellow lanyard, and we're going to get you in touch with some of the right people for you to be talking with in order to continue conversations, because there's a lot of exciting work that goes on here. One of the things with these real-time 3D engines, right, is we have these interactive environments where we're modeling problems and we're able to safely try various solutions, right, which is great for swarming simulations because, buying 100 robots, let alone maintaining 100 robots, right, is a pretty serious challenge. But if you're interested in the algorithm and want to make sure that your algorithm's right before you go and buy a whole bunch of robots, then you want to do that in silica. So those are the kinds of the modeling and simulations that happens. But that also includes things like reinforcement learning, which is a newer technique, which, in many ways is a solution optimization approach. But by having an environment, if you understand the problem and you can grade the solution, then you can have a system in there trying to optimize how it carries out a solution to get the best grade it possibly can. When we're also talking about distributed simulation, large simulation, DIS and HLA are two fundamental networking approaches that are used a lot here at APL. So James Dean's going to be talking about integrating DIS with Unreal Engine. And then GIS, anytime that we start talking about problems that are outside of just, pure theory, and we're looking at robotics or swarming like that, we need to start talking about real-world environments. And so as soon as you start talking about real-world environments, now you're talking about GIS. And there's a bunch of concerns about using GIS in game engines and getting the two to work well together. So Annie's going to be talking about GIS and game engines, some of the gotchas that you might need to be aware of, especially since a lot of the entertainment industry doesn't care about the level of fidelity that we're going to care about. And of course, that's just the APL stuff, right? Those are the folks that I work with and talk to. And there's a far more going on in the field. So we have some of our colleagues from industry, from other academics and from NASA Goddard who are here to talk about the things that they have going on. I haven't previewed any of those talks, so I'm very much looking forward to seeing those talks themselves. But I don't, we've been talking about what's going on at APL, but there's a lot more going on. And so we're excited to see a lot of the cool things that are going on across the board. All right. So that's APL and kind of the work that we're seeing and why we care about it and how it relates to the various talks that you're going to see here at the symposium. Let's talk about the industry and what's going on there. Technology is continuing to do what technology always does, which is smaller, lighter, faster, better, more comfortable, and it's really valuable, right? And now what's interesting is we're seeing a number of companies taking this in different directions and doing different things with it. So as some of the technology gets better, right, say you get more power efficient, there's a few things that you can do. So first of all, you could just make your headset smaller, or you can get more battery life out of the existing battery that you have, right? And so we see some people doing that. Or, some of the device manufacturers like Vario, they're going to take those same advancements and they're going to say, we're going to take our current technology, we're going to continue to push the fidelity and make that more efficient, right, and push on the higher end. So some people use it to make, lighter, smaller, more comfortable devices, and then other people are going to use it to continue to improve and refine their higher end devices. And we're seeing this a lot in the industry, right? We're seeing a lot of differentiation. It used to be that everybody was coming out with similar kind of devices, right? The original Vive and the original Oculus, they did things differently. The approach to tracking and whatnot was very different, but fundamentally it was a headset that was connected to a PC. They had similar resolutions, and they did a lot that was pretty similar. We're seeing a lot more diversification of the market as companies are looking for their individual niches. There's been no shortage of big headlines about major layoffs across the tech industry. And so what we're seeing is Meta, for example, has decided to slow down production, and eventually they're going to stop production of the Quest Pro line of headsets because they're focusing on the Quest 3. And that doesn't really surprise me because their whole intended audience for as long as Meta has owned Oculus has been to get headsets in the hands of the mass market, right? That's why the Oculus Go was a thing. That's why the Quest was such a big hit. And so their whole goal is to have very consumer-friendly, hands-on devices that everybody is just going to go out and buy at an affordable price point, right? That's not Vario's approach, right? Their approach is going to be much more high-end, much more quality-focused, much more designed about, visuals first and then, other factors secondary. You're dealing with Apple, right, who sees themselves as a luxury brand. And so they're not going for that mass market, right? They're starting at $3,500 for their introductory headset that nobody's ever tried before. That's a pretty bold move, but it's Apple, and so they can make that bold move because they are a luxury brand that people know and understand. And they're going to do some things right? Apple is known for their super high quality visuals. They're going to have beautiful screens in that device. That's what they do. My hope is also in an industry where hand tracking has been acceptable, but not super awesome, Apple's dedication to a refined user experience will hopefully introduce a product line that raises the bar for the rest of the industry, and that everybody else has to kind of step up and improve certain things, especially algorithms like a lot of the hand tracking that's going on. So we have seen some companies bow out. Google has recently canceled Iris. Meta, Facebook is focused on the Quest 3. We're still, a year ago, we weren't sure what Microsoft was really up to. We're still not really sure what Microsoft is up to. They're continuing to develop and deliver IVAS, but we haven't heard any word of HoloLens 3, so I'm not expecting that anytime soon. Microsoft is, I think, going to be focusing on what Microsoft is best at, which is software. As we see these major players move and make changes, again, they're defining themselves in little niches. There's a lot less overlap between devices. Vive is continuing to challenge things a little bit, but their focus, again, seems to be more developer business focus than, say, the mass market, which is where the Quest is very focused on. The other big thing that we're seeing happen is that standards are taking hold. OpenXR is a really big deal. I know for non-developers, it might not seem like a lot to see some standards bodies come out, but things like the Metaverse Standards Forum or the use of standards like OpenXR is a really big deal for developers. It was only a couple of years ago that if you wanted to develop an application, you would develop your VR app, and then you'd have to have the Oculus plugin or the Steam plugin or the Microsoft plugin or whatever, and that then to go to another platform, you had to rip that out and then put in a whole other thing. And we talked about in the Technical Digest back then, we talked about having an interface middle layer so that you weren't directly implementing these frameworks deep into your code, right? These standards, what they're allowing us to do from our perspective as scientists, engineers, and people who are producing tools and results for the DoD is absolutely immeasurable, because what it allows us to do is avoid vendor lock-in, right? Because we are no longer beholden to one particular headset, and it's no longer this giant effort to get out of one headset and get into another headset. Yes, controllers are different, buttons are different, placed differently, or they might have a different complement of buttons. There's a few adjustments that you need to make to go from one to another, but it's not this giant months-long effort of moving from one device to another. So we have a lot of flexibility in terms of how we use our game engines because the standards underlying those game engines have gotten much more adopted across the industry. So immersive technology isn't the thing. It's not the end thing. It is the thing that gets you the thing. VR and AR is not of much value by itself. It's what you do with it, which also means it is very important on what you integrate with. So what's going on in other industries around the world has a major impact on the things that you can and can't do with your XR headsets. So the first thing, and that was a problem a year ago, is that the crypto markets were still very high, and we couldn't even buy the equipment that we needed. Like, it was not on the shelves. It was not a thing that we could buy. Last fall, winter, crypto took a major nosedive, And that means that graphics cards are affordable again, and that we can actually go out and they're in stock and we can actually buy them. And so that we can have the very high-end graphics cards that we might use on, a super high-end headset, right? Graphics cards are also improving dramatically. The year-on-year improvement is not to be ignored. It used to be, a couple of generations ago, only certain graphics cards were good enough for VR stuff and other cards weren't. Now pretty much any commodity graphics card that you can buy will be able to drive some VR experiences, right? That if you're buying a system with a discrete graphics card in it, you'll probably be able to run your VR stuff. And, on the high end, when we're talking about some of these big simulations, as a software engineer, I deeply want my code to be just perfect and clean and fast, right? However, as a researcher with a researcher budget and a pragmatist, sometimes I look at that and go, I don't have 2 weeks to super clean up this hunk of code and make it optimal. But if I just buy a bigger graphics card with more video memory, it can hold the whole problem in its memory, and then I don't have to spend 2 weeks optimizing it. The truth of the matter is sometimes you can buy your way out of a problem. And when you can do that, it is very often a good idea to do that. So the fact that these cards are, one, getting better, and two, actually available, has been a huge enabler. And this also starts playing more and more into, and we'll be talking about it in a minute here, artificial intelligence, and when we start integrating some of those things into the experiences that we're working on. Game engines continue to improve. Now, I'll be honest, there's a ton of game engines out there. There's only two that you really care about, and those are Unity and Unreal. Godot is a distant third. It's coming up. It's trying very hard. It is not there yet. Unity and Unreal are by far the two engines that are dominating all of real-time 3D right now, and especially augmented reality and virtual reality, because they're the ones that are implementing those standards that I was talking about earlier. So almost everybody is using those two engines. The previous advice about which game engine to use absolutely still stands. It's been my standing advice for the last few years, but I know we have some new folks here. So here is the fundamentals of how you should be selecting your game engine in 2023. You need to look at your team and understand your team and what their needs are. And then you need to understand the audience of the two big engines and what it is that they're trying to do and the teams that they are trying to serve. The Unreal Engine is a big, powerful, beautiful game engine. It is aimed towards artists, and it is aimed towards authoring big AAA titles that are absolutely top-notch in quality. That is the team that they are aimed at, right? Many of those big AAA titles are dozens, if not hundreds of artists, right? A few programmers that are working on a big budget project at a time, or maybe two, but they're very focused on developing a singular experience where you have a whole bunch of voices and that everybody is specialized, right? In the Unreal Engine, it is designed so that you have your technical artists, that you have your engine programmers, that you have your gameplay programmers, you have your world builders, that these people have separate roles and that they are very focused on that and that they collaborate together. It is a fantastic engine, and it has incredible technology going into it. And it is designed for those big budget things. The Unity engine is designed for smaller teams. It is designed for indie game development, usually 1 to 5 people, right? These are people that are jack of all trades. They wear many hats. They do many things. And so what happens is if you have a very small team working on Unreal, they spend a lot of time trying to learn all of the parts of the engine, which is very difficult. Or if you have a large team working in Unity, they end up stepping on each other's toes because Unity is designed for people who are jack of all trades. And so everybody tries to be a jack of all trades, and everybody steps on each other's toes. So notice nowhere in here am I talking about license costs for the engine, because that does not matter really. the amount that you pay for the engine should be one of the least important things about the engine, because choosing the wrong engine for your team is going to result in a huge amount of wasted time and effort that will dwarf any licensing costs that you could possibly throw at it. Making sure that your team has the right tools for the job that they are doing is absolutely vital. Now, I will say there are cases that will trump this fit the engine to your team ideology, and that is if you have a specific need for your game engine that the other game engines don't have. So, for example, there are hardware devices that are Unity only. So I guess you're going with Unity. Like, that's pretty much your option, right? That Unreal doesn't work effectively on them. Unreal is also developing some very powerful cutting-edge technology. Lumen and Nanite in particular are extremely powerful engine capabilities. So if you're building a world that has huge amounts of deep, rich texture and geometry that you need to convey, Unreal is going to be able to handle that natively better than Unity is. So there are a few edge cases where the technology of one or the other may eliminate a game engine as an option, right? But generally speaking, for most of the work that we see going on, either engine is going to be able to be more than capable of handling pretty much whatever your software engineers or artists throw at them. And so either engine is good. Choose the one that's right for your team. AI-powered technology, it's another big thing that's going on in the industry. Real-time ray tracing, deep learning supersampling. Again, these are providing more options for developers. So I'm going to talk about them in a little bit more detail in a bit. But again, what we're talking about are technologies based off of the graphics cards that we're seeing come to market that allow developers to have more choices as to, do they run on smaller hardware and be able to upscale the images, or do they want to be able to run on bigger hardware and have more detail in each image, right? So these are deep learning techniques that will allow the software developers to really have more options, more sliders that they can adjust as they develop solutions for a particular audience to help you meet your goals. And so that might help you meet your size goal, or that might help you meet your visual fidelity goal. And then generative AI is going to make a major impact on our industry. There, I think, is going to be, and there already are growing pains in industry. We're seeing a lot of social commentary about it, but it is a major disruptive force on both how the games themselves are developed and how the games integrate with other systems that are going to kind of change what we're doing and how we're doing it. And it is a much more real, impact that we're seeing today than we would have seen this time last year. So we're going to talk about that in more detail. AI and immersive tech. So once upon a time, when I was young, and both of these industries were young, I could actually keep track of what was going on in both the immersive technology fields and what was going on in the artificial intelligence field. Nowadays, we have the XRCC team. We all are going out and looking for news to be able to keep track of everything that's going on in the XR field. And if we think that the XR field is moving fast, that involves hardware, which slows it down. The AI field, the only hardware that is involved there are graphics cards, so that's moving at just a blinding pace. Keeping track of everything that's going on in both of those fields at once is more than any single human can do. Or at least it's more than this human can do. But just because we can't keep track of all of the new algorithms and all of everything going on doesn't mean that we can't make use of AI and understand how AI can be useful to achieve real engineering progress and support the solution of some of the challenges that we and our sponsors face. right? So I've broken it down. Most of the time that I talk about AI or see AI talks, they talk about the AI architecture, right? That this is a, variational autoencoder or, whatever. But the truth of the matter is at the level that we're interacting with the systems, we don't actually care about the underlying implementation architecture of many of these AI algorithms, right? But we care about is that they exist and what do we use them? How do we use them? What do we use them for? How do we use them? Right? So I have three main classifications of AI. And one is an AI subsystem. And the nice thing about an AI subsystem is, generally speaking, it's not our problem. Right? We need to know that there is a deep learning network or a classifier or something going on under the hood, that there is some kind of AI there. But generally speaking, it is a system that we use. We are not implementing it ourselves. We are not tying into it. It is a thing that we leverage, but other than that, we can be pretty much hands-off. So, for example, hand tracking is one of the big things that has been a huge improvement in the last few years. The hand tracking in many of the commodity VR headsets has grown and improved dramatically. Now, it used to be that to get improvements in computer performance, right, or improvements in the output of a system, a lot of times you'd have to buy new hardware and put it in there. Well, what these commodity systems are doing is they're just using cameras, right? And they're just getting better and better and better about how they use the cameras. And so we're seeing massive improvements in the fidelity of hand tracking. So last year, again, we were talking about this. I said, we still, it can track hands, but I can't thread my fingers together and it won't track it right. Well, now it does, right? And these are the exact same devices. The hardware hasn't changed at all, but they've improved the training, they've improved the algorithms, and so the hand tracking has gotten better and better and better. It continues to improve. Data compression is another one. Things like variational autoencoders are pretty popular here, and we're seeing it in a whole lot of areas. Netflix has started implementing it and how it does data streaming. So essentially trying to have adaptable data streams that are really efficient at compressing and decompressing data. This becomes really important for things like remote rendering, where maybe you have a device and you don't want that device to have all of your 3D models and sensitive data. You just want to use it as a display. So you want to stream that data from somewhere else. Well, having a good data compression algorithm means that you're not having to re-engineer your entire network just so that you can try to stream data from your PC over to your headset. Right? So this is an area where we're continuing to see gains and improvements that we really didn't honestly expect like 3 or 4 years ago. But that data compression is improving and that it is enabling us to solve problems by keeping sensitive data off of headsets that, again, a few years ago weren't even possible. And that we can expect that these data compression algorithms and similar things will continue to improve, and so they will enable us to be able to do what it is that we need to do. Speech to text, pretty straightforward. It's continuing to improve. It is something that we use. We don't have to implement it ourselves. We have to tie into it. But thankfully, we're not trying to write the next great speech to text algorithm, at least not that I'm aware of. These other two classes are more interesting because they actually involve our interaction in some way or another. So there's good enough problem solvers and then generative models. I'm going to go into more detail about these two classifications of AI because we actually have to do something to be able to leverage them. All right, good enough problem solvers. So these are AI designed to very quickly come up with a solution to a problem that is good enough. It's not going to be perfectly accurate. It's going to be okay, right? But as we talk about requirements and understanding the engineering process and understanding what people need, a lot of times good enough really is good enough, right? So ray tracing is a phenomenal example of this. It used to be you'd go to the movie theater and you'd see the latest 3D big budget animated feature and it would be gorgeous. Right? And they have subsurface scattering, and they have all of these reflections and lighting, and it's beautiful. And that's because each frame of that movie probably took seconds, if not minutes, if not longer, to render. And so that's not interactive, right? On the other hand, we had, rasterization, which is the traditional approach for game engines to be able to do lighting and to take, 3D geometry and throw it on the screen. Now, when we're rasterizing things, we do have some lighting, but it's very expensive. And we'd have reflections, but we'd have to do some screen space trickery to make things kind of look like reflections, but they weren't really. And so you had either high-end, super gorgeous results, or you had results that were okay. But now with the advent of real-time ray tracing, and specifically denoising, which it turns out is a Monte Carlo problem, which is interesting because Monte Carlo is applied to a lot of other research and work done at APL, you can actually take that lighting information and have a middle ground where it is more immersive, where it is more believable. And a lot of times I'm talking with people and I'm talking with engineers and they're like, yeah, but it's just lighting, right? Like that doesn't matter, right? It's not that important. Of course, it's lights, whatever. And if there is an artist nearby, I consult the artist. And then I explain to them, light is the whole reason we see anything, right? Everything is driven by light. All of what looks believable is all driven by light. Light, if you are an engineer and you had to go and learn one area of art anywhere, I want you to go and understand lighting and play with lighting and learn about lighting in more detail because it has an impact on feel, it has an impact on believability, it has an impact on mood. It will change how you communicate with your user. It will change the message your user takes away, which is part of the reason why we have talks about things like learning from the film industry, right? Lighting matters. And so having tools that help us provide better quality lighting in speeds that allow them to be interactive is, again, that's a huge gain, that's a huge win for us. Another one that I'm playing with personally, and I have a demo of it at the end of the day, is water. Water is something that in games traditionally was very static. There's a waterfall in the distance, right? Or there's maybe a puddle of water and you fall in that and your character dies, right? In a few more advanced ones, maybe you have a boat that bobs on the water. Oh, that looks cool, right? Fluid dynamics is a really hard problem. And we have experts here at APL that can go on at length and detail, who are passionate about, who have made these kinds of things their life work. But the problem is that those calculations are really, really slow. And that having something that you can interact with is an extraordinary challenge. And so again, having a good enough problem solver, what that means is, in my demo, nobody is going to be fooled into thinking this is how water actually really behaves, right? It's not going to be nearly as good as the real problem solvers. But it is good enough. It unlocks a new interaction that you're playing with something locally, close to you, that you can splash, you can play around. And that's not something that we've ever really been able to do in any kind of fidelity before, right? And so there are going to be other areas like cloth simulation, which is, again, it's important and it's challenging and it is so fundamental to how we are used to interacting with the world, but computers have a really hard time with it. And so by being able to speed that up and make more believable, realistic interactions, we think that we're going to be able to unlock new capabilities and new ways of communicating with our operators that we haven't been able to do before these good enough problem solvers existed. So usually in this case, we are not writing these algorithms. We are integrating these algorithms from somebody else. However, is that somebody else? That could be somebody else within your organization who is a specialist who is developing that algorithm, or it could be just a commercial off-the-shelf algorithm that you're able to buy. Or in the case of the real-time ray tracing that is implemented by your game engine. NERFs. NERFs are, they're new. They're one, if there was going to be anything here that I think I would say that nobody here has probably heard of, or only a few people have heard of, it's probably going to be a NERF, neural radiance field. When we start talking about solving problems, there's always a where. Where are we solving this problem? Whether it's the cockpit of an aircraft or it's a location, right? There's always a where component. And it used to be for us to get a viable version of that location for us to make use of it, we would have to go in and model it manually, right? And so we would go and we would measure everything and we'd take a whole bunch of pictures and we would spend hours and hours and hours rebuilding a digital version of a physical thing. And that is extraordinarily slow and time-consuming and a giant pain. A few years ago, with the advent of HoloLenses and iPad Pros and other devices with the LiDAR built in, we were able to take those devices and we're able to walk around and we're able to get a rough 3D scan of those objects. And that was a massive accelerator, right? So instead of measuring everything manually and hoping that it's square and hoping that you did it right, you can go through, get a 3D scan of it. In a lot of cases, you weren't using that 3D scan directly, but now you had a framework that you could use to build your model off of, and that was a huge improvement. At the same time, we have photogrammetry. In photogrammetry, you go around and you take a bajillion photos of everything, and then you have an algorithm stitch it together, and then you have to go and clean it up. And it's still a lot of work and manual labor, but it was, again, a vast improvement. And certainly some of the high-end 3D environments that you'll see in some game demos and whatnot, right? Those are real environments that have been used photogrammetry to scan them. So a neural radiance field is a little different. It is most like photogrammetry. And so you're going around and you're taking a bunch of pictures and then you're feeding it, you're training a neural network to reproduce that environment from any angle. But what's interesting in some of the NERFs that we're seeing now is that it's not just producing geometry. So all of those methods that I've talked about before, they are generating geometry and they are generating texture, and that was it. One of the things that's interesting about NERFs is that they're starting to capture the light field that is actually creating the scene. So now we're getting reflections that are correct because light is directional, it has a source. And so that's getting embedded in this neural network. Now, it's still early days for NERFs. They're not something that I'm gonna say, oh, go out and implement this and use it. But I wanna put this on people's radar because I think for a few of you at least, it's only a matter of time before we're getting hands-on with NERFs and that we're using them in our game engines to help us build believable worlds, especially with better lighting. Generative image AI. So when I'm talking about generative AI, I am going to avoid many of the legal issues surrounding it. They are there, they are real, and the truth of the matter is, if anybody tells you they know how all of that's gonna fall out, they're either kidding themselves or they're kidding you, right? We do not know. This is new territory. It is interesting territory. But I am not going to talk about the legalities of it because the truth of the matter is we do not know how that's going to fall out. What I will say is with generative image AI, there's enough companies involved with it that I don't think that the whole thing is going to get squashed in some judicial ruling, right? There's too much going on, there's too much money, there's too many approaches that I think generative image AI is going to be here to stay. And I think that the advancements in generative image AI are frankly mind-blowing. So I used myself as an example, a guy with a mohawk giving a talk, a mohawk and a goatee giving a talk at a symposium. And so I ran that using Midjourney, and I used the very first version of Midjourney, which was from February 2022, and then I used the version from June of 2023. So 18 months have passed, and we've gone from bizarre, weird, avant-garde, mishmash, something which, you know, captured the imagination but wasn't particularly useful for much, to a stock image, right? And then we also have this image of this game that does not exist. And so I basically told it, I want an image of a dreamy landscape with, you know, that's very colorful and vibrant and floating islands. And this is what it came up with. Now, This is not going to replace an artist. Just like having an AI algorithm generate one function does not make it a programmer and you're going to throw away your programmers, generating one single shot of a concept image is not going to replace your artists. But what it does do is allow you to have better communication with your artists. Because one of the things that is very difficult at the beginning of an artistic enterprise is communicating the base ideas to get those concepts out on paper. I do a little bit of art. I am nowhere near an artist. So even communicating my ideas is very challenging. But if I can sit down and spend half an hour with an AI and say, hey, I want something like this. I love this color palette. How do we take this feel and apply it to our project? How do we get this kind of dreamy concept? And we can look at the lighting and the color and the composition, and then we can do something with that together. But that's a huge time saver so that we don't have to do absolutely everything from scratch every time. 3D model generation, we're not there yet. It's on the horizon. This is going to be, I think, a big enabler when it's ready. It is not ready for show. This is kind of like our hacky Midjourney 1.0 variant, right? You type in a prompt, it comes up with a model. Is it any good? I mean, it's clearly a penguin. It's clearly a banana plane. You can see what it is, but this is definitely very 1990s, early 90s game art. Like, this is not ready for prime time. I think this is going to mature more slowly than some of the other generative AI because of there's less training data, but it is continuing to develop. This variant is using Shape-E. It is a massive improvement over things that we have seen in the past. It's going to continue to develop. It's going to continue to improve. So keep your eyes on it. Not ready for show. And then, of course, the big generative text AI. This is, a bajillion news articles are talking about this. We have to talk about this because it's important. So this is your ChatGPTs and your other large language models. And they are powerful. But I think a lot of people, as they're working with these, are starting to understand, but it isn't communicated well, that these tools are powerful, but they don't solve problems. So they have read, for lack of a better way to scope it, the internet. And everything good and everything bad, they have read scads and scads and scads of information. And so they are very powerful and useful for things, such as they have trained data. The data that they've been trained on is very broad, so they might have some perspectives that you don't have, right? So if I talk about database design and engineering, the last formal training that I got for that was probably 1998. And so there's been a lot that's gone on since then, and that if I'm interacting with these systems, that it's read those documentation and articles, and it's going to have some perspectives that I don't have, and maybe even sometimes some that I don't agree with, but at least it brings it up, and then it gets as a starting point without me necessarily having to go through all of these articles to get down to what are the parts that I don't disagree with, or that I don't agree with, or what are perspectives that I might not have. It is a fast and polished writer. Now, I know I have some writer friends that says, Blake, it is never going to produce anything more than mediocre. And I am okay with that, because if you saw some of my first drafts, they are not mediocre. I am aiming for mediocre. Right? I am, over time, given enough time and energy, a fairly decent writer. I have articles in the Tech Digest. You can judge for yourself. But it takes a lot of effort for me to get there. So if I can just get my ideas down, one, and then put them in something that is going to polish it up, remove all the extra parenthetical statements because I use too many parenthetical statements, clean up my writing, improve the quality of my language, spit something out that I can then take, edit, refine, and then go from mediocre to good, I have saved hours in there. But what I didn't do is have it write the article from scratch, because that is extremely dangerous. Only some of these systems can cite sources, and almost all of them will hallucinate. They will just make stuff up. Their job is to generate, and they love to generate. In fact, one of the biggest problems that I have with generative AI right now is that it loves to generate so much, I cannot get it to stop. It is generating pages and pages when I'm like, I need like 3 sentences, right? Now, you can tell it, hey, can you make that more concise? Can you narrow that down? And so there are things that you can do, but you still need to be mindful that they will hallucinate, they will make stuff up, and they will be very convinced that they know what they are talking about. So you need to do the double check. So there are times it is easier to edit content than to add it from scratch, right? Because you're not sitting there going, oh, what's the phraseology that I want to use for this, right? So sometimes having it generate boilerplate for you, right? You can go through and you can edit it, and you can do that much quicker than you would if you had written that yourself whole cloth, right? But you also don't want to just necessarily turn that over to somebody, right? You know, we have some interns that are doing really important work and really good work, but if they write a report for me, I am going to read it before I hand it over to a sponsor and put APL's name on it. Like, you know, to do otherwise would be, frankly, a dereliction of my duties. And this is that, but even more so, right? You're not just going to blindly take some report and hand it over to a sponsor. You need to make sure that you are reading it, you are understanding it, that you're editing it. You have to do it quickly, or you have to do it critically and not quickly. You know, much like you know, integrating something from Wikipedia or some other, you know, public source. You can't necessarily trust it. So using it, again, it's designed to provide information, not solve problems. Now, that said, it has read all of the documentation. And there are times where that is really, really nice. So game engines are big, right? As I said, Unreal is too big for any one person to know all of it. Honestly, Unity is too big for any one person to know all of it. I was working in a part of Unity that I hadn't worked in years, right? Which is 2D user interface code. I couldn't remember some of the syntax. I knew that there was some weird edge case to some code, but I couldn't remember what the syntax was. Well, I could use a large language model, and I could put it in, and it would tell me, because it has read all of the documentation, right? And again, is the code that it spits out phenomenal? No, it's okay. But that's better than me fumbling around in an area of code that I didn't know before because I wasn't familiar with that portion of the API. It knows industry trends. It has a lot of advice, both good and bad. One of the most interesting things that I did was I took my language model and I put it on a feedback loop. And I just said, hey, what do you grade this code as? And make it better. And then I would take the result and I'd feed it in and I'd see how good it got, right? What is the rating 1 out of 10? What do you give it? And I started feeding it code, and it started with 5 out of 10, and then got up to a 7 out of 10, and then down to a 6 out of 10, and that's pretty much where it stayed, is a 6 or 7 out of 10, because it is essentially coding by committee. It is every concept from every author, and so it would give conflicting advice because it's not really supposed to solve the problem for you. These systems have a very limited context, right? They only understand the problem as the one little piece of whatever text it is that you have given them. That is all it knows about the problem, and therefore the solutions you get are going to be like you're going to get in an introduction to programming class, where you give an assignment, you don't have any other context, they don't, you know, the students don't have good understanding of software engineering practices, they're just trying to, you know, learn what an if statement is for. And so they come up with a solution that solves the problem without being part of a larger solution. And that's exactly what we're getting out of these generative AIs, right? So it is with time and experience that we start to understand the larger context. It is with the experience of going on the ships that we understand the context of the warfighter and how we solve those problems. It is the context which allows us to make sure that we have efficient, clean, elegant solutions. And frankly, these AI systems don't have it. But what it can do is make your solution better. So again, much like the first draft of the writing that you did, you can have a first draft of a hunk of code. It's like, you know what? In programming, there's this general concept in test-driven development, red, green, refactor. right? Go from red to green, from not working to working. And then you're supposed to spend just as much time going from working to cleaned up before you submit it. The problem is, people don't, nobody does. It's one of the biggest problems with test-driven development. The concepts are great, but in practice, people skip over refactoring, and that's how you end up with a large amount of technical debt. But with these AI systems, you can take your solution and you can say, hey, go clean this up for me. Put in those null checks, right, that I forgot to put in there, right? Add some comments so that this is better documented code. And it is going to come back with a result that is likely going to be better than you necessarily fed it. And so what's nice is because you have already solved the problem once, you can then test it to make sure that the solution still works, right? So now that you have refactored that, you have better looking code. Is it going to be beautiful, miraculous code? No. Is it going to be mediocre? Yes. But are you going to be embarrassed? Right? There have been times in my career where I'm like, yes, here's the code for this thing that I solved, on a weekend 2 years ago, and don't look at it closely because, it's really ugly. Any programmer who's programmed for more than 15 minutes has felt that at some degree when somebody else has looked at their code, right? You run it through one of these things, it'll clean it up, it'll make it look nicer, you'll be less embarrassed by it, you'll probably eliminate some bugs down the road. But again, double check the work. Also, translating from one programming language to another, it's very good at that. Explaining unfamiliar language structures. Maybe you run across something, somebody used an approach that you're not used to. It's read all the documentation. Ask it about it, and then you're not embarrassed. You're not feeling like, oh God, am I an idiot? Have I missed some major advancement in software engineering? No, you can just ask it, it's not a big deal. And again, refactoring code is what we talked about. Make sure my null checks are in place. Make this code more concise. That's a great command. I love that, right? It's just clean this up, streamline it for me. And it's going to yield better results than writing it from scratch. Now, with those in mind, here's my guide to using generative AI in 2023. Seek guidance on how you can use it. The legal issues surrounding it are non-trivial. Have that discussion. Understand what it is you're using and how you're using it, but don't accept a blanket, we can't use that. Some people are just going to say, nope, we're going to be hands-off, we can't touch it. The truth of the matter is if we have somebody coming in behind me and refactoring my code after I write it, we're going to run circles around people that don't have that. And if we're not running circles around them in the short run and delivery, I can guarantee you we're going to be running circles around them in the long run when we get into maintenance mode, because I'm going to be maintaining cleaner code than somebody else is going to be maintaining, right? Understand where your input goes. If you have things that are your secret sauce, you might not want to just be dumping them into the latest large language model from, I don't know, China or somebody, right? Like, you need to be mindful. That said, a lot of the companies that we're seeing, right, are investing billions of dollars into having these language models available. They're organizations that you likely already have some agreements with in place anyway. Have that conversation, figure out where does the data go. There are also some that are happening offline as well. But very often if there's already a company that you rely on and that you can have a good partnership with them and that you know that they're going to be keeping your data safe and secure, that's going to give you a lot more confidence and comfort when you're implementing and using these AI systems. Use it as a brainstorming buddy. Use it as a tool to help you refactor your code. But again, you never fully trust it. Have a way to verify it, whether that means you're spending the time and going through reading it yourself, or if it's refactoring code that you already have some ability to test its output to make sure that it is not just outputting junk, because it can, and it will. And of course, no talk will be complete without talking about AI and XR in the future. So I talked about all of that so that we can talk about this. That context piece is super duper important. That is why AI right now is not very good at solving problems, because it doesn't understand the operator, it doesn't understand the operating environment, and it doesn't understand the constraints of the problem. And the truth of the matter is that with a text prompt, typing all of that in, if you go through and thoroughly define all of that you've done, you have essentially gone 2/3 of the way or more of actually solving the problem yourself. Right? So much of the problem is figuring out what exactly the problem is. So by the time that you've defined all that context, you're already very close to a solution. However, in the future, immersive technology devices, I think, are going to be one of the keys to really unlocking the potential for using AI to solve real-world problems, because they know, in previous years we've talked about, these devices are the most personal computing that has ever been. They know where you're looking. Some of the devices know what your heart rate is. They know where your eyes are. They know how engaged you are. Some of them have an idea of how cognitively involved you are, where your hands are, how your body is, what your room looks like, what's in your room. These have a huge amount of context about the operator and the environment in which they are operating. And with that context, that's going to be what enables these AI to be able to come up with answers to problems that are much more relevant and much more focused on solving the problems that the operators are encountering in real time. So that's me, that's my talk. We have just enough time for one question and see where we go from there. Yep, yeah, and there's a microphone in the back, if you will. Yep.
Hey, Blake. Lucian Parsons. Talking about the AI, the generative AI specifically, you mentioned the legal issues. Are you seeing anything to say that that is going to be resolved anytime soon? Or do you have any hints about how to avoid those specific issues?
I think it's going to be a long, bumpy road. It is interesting because we have seen the start of some initial feedback, when we talk about ownership and copyrightability. We've seen all of the feedback that I've seen from the federal government at this point, I think it was the USPTO, has said essentially that if you put in text and it spits out an image, no human was spitting out that image, and therefore it is not a human work and is therefore not copyrightable. That is the guidance, that is the most up-to-date guidance that we have. There's another portion of that, right? The flip side of that is, how did that image get created and what data was used to train the model to create the data? And because there is a lot of question about, have those models been ethically built? And I think there's going to be a lot of question about the ethics of building those models and where the data is from and how it gets used. And so there's going to be a lot of question. Do you have the rights to use those images to train this model? And some of these companies are absolutely designing themselves so that they can answer that yes. And other companies probably are not able to confidently say that yes. But yeah, those are the big things. I don't think they're going to be resolved anytime soon.
Adobe says that they will, if you use their system, you're covered.
Right. Adobe says if you use their system, you're covered. And so and that goes into, what are your agreements with Adobe? Right? And do you trust Adobe? Because, we're seeing similar things with, other companies are saying is, if you use OpenAI directly, your data that you put in there is going to be used to train the model. But if you use this other company's implementation of OpenAI, that will not be fed back into the model for training. And so then there's a question of, do you trust those agreements? And there is a point at which, you really do need to, you may have a discussion with your legal team, but at what point do you say, I individually care about this, where does our organization care about this, and where do we draw the lines? Yep. Sorry.
Speaking of what you were just talking about, AI right now being a black box, at what point do you see people moving into open source for AI?
So the question is, right now AI is a black box, and when do we see people moving to open source for AI? It's starting to happen now. It depends on the kinds of models that you're using. Again, like NERFs, I think are much more open. I think the thing with the large language models is just the amount of data and processing power needed to train them is part of what's driving those to be a little more private. The AI industry as a whole tends to be very, very open. And I know here at APL, explainable AI is a pretty big deal. Right, and last question.
Hi, Mitzi Herrera from Montgomery County, Maryland. When you look at a lot of ChatGPT, it is a textbook copyright violation. You took something in a fixed form and you've copied it. Why do you think that we haven't seen more of Hollywood copyright holders, Disney, looking more closely at it, raising those red flags? And do you see that as something, as you start to look at taking code, taking other things, and copying them, do you see that as something that it's going to be on the horizon, something that's going to be raised as a bigger issue?
Right. And so, one question is it a copyright? In many ways there is some question about, who are the rights holders and what do they get to say that you can or can't do. I think a lot of it is, when we come up with images, right? What are the terms of service? People upload their images to Flickr. All of a sudden, Flickr has non-exclusive rights to be able to do whatever they want with the images. And so people are saying, oh, that's a copyright violation. And Flickr can say, well, not really, because our terms of service say that we can do this, right? Adobe has similar things. So it's very, very unclean. And so, yeah, that's why we are seeing legal action forming up, and it is starting to enter the courts. And it's going to take some time. Again, these technologies are a year old publicly, and so it's going to take some time for it to work through the court system. And really, we just need to wait and see and make sure that we, as that happens, we adjust ourselves and use the technologies that are in accordance with appropriate use policies for organizations.